yield time. Notice that if our significance level was 1%, we would have failed to reject. So depending on your significance level, you can be a little bit more of a stickler with regards to like how loosey-goosey we want to be with this test. 5% is still pretty low. You're probably fine. It's better than 10%, which is better than 20%. But just be aware of that the significance level can then adjust like when we do or do not reject. Okay. Next example, 2 sample, I can tell automatically because we have 2 rows that are 2 samples and it's a t-test. Because we're not talking about frequency, we're not talking about categories, we're just talking about samples. So we're probably talking about averages of that sample. 2 IB schools would like to compare their test results. They randomly pick 10% of their second year students and check their test results on a test where the maximum mark was 60. The table below shows the results. Assume the test results follow a normal distribution and the variance is the same. This is something that's important to note. You'll see this in some questions, and maybe some questions might ask you, what assumptions are we making here? With a 2 sample t-test, you are assuming that the 2 samples come from the same they both come from a normal distribution, not necessarily the same normal distribution. That's what you're testing. And they have the same variance. They have the same spread. They have the same variability. So you're pulling from populations that have similar variabilities. You're not trying to compare apples to oranges is kind of what it's trying to say. You're not trying to compare a school in Italy to a school in southern US, right? You're not trying to compare 2 things that are like very different. So they're trying to say, okay, we're assuming that it's coming from a same variance, and then we're going to test to see if it comes from the same mean. Okay, so we're going to state the appropriate hypotheses. Of course, the null is always that the averages are equal to each other. I'll go ahead and label school A as mu1 and school B as mu2. And then I have to look back at the text to try and figure out what the alternative is. And I'm going to have you try to do that on your own. It does say in the text up here, it's just they would like to compare, right? There's no wording about school A is more advanced or school B has better test scores, right? They're not saying that we're trying to test a claim that it's better or worse or anything like that. We're just saying we're comparing, which means that the alternative is just not equal, not greater or less than, because that's not what we're looking at. We're not trying to see whether or not something's greater in this situation. We're just trying to see, are they about the same? Okay. So now we have our alternative, and I think you can run this test on your own. Notice there are missing values in this table, and that feels weird. You actually don't have to have the same sample size in a t-test. It's fine. It's okay that those are blank. It's okay that you won't have the same number of numbers in your spreadsheet. So you just put in that data exactly as you see it and just leave these guys blank. It's totally fine. All right, go ahead and find the p-value. So remember, we go into our spreadsheet, we put in our 2 columns of data, we run the test and tell about all of the results, make sure that it's pooled, make sure we have the right alternative hypothesis. The p-value that we get should be 0.27083. 3 sig figs would have made that 2.7. We're told to round up, so 271. If that is not what you got, some things to check. Try it again. Make sure that you did pooled. Make sure that your alternative hypothesis was done correctly. And those are typically the biggest mistakes that you can make. Okay, now it just says to draw a conclusion at a 10% level of significance. So we say since 271 is greater than 100, P is high, so we fail to deny. It does not ask us to interpret, but we're going to interpret anyway, just to have practice on it, and just in case we forget to notice that they tell us to interpret. So if we fail to reject, that means that we're accepting the null hypothesis. The null hypothesis is that the averages are about the same. So this means that the 2 schools have similar test scores. Okay, last example. Example number 5 is a stats example. It looks like it would be data because we've been given another table, but keep in mind that in the table, it's average and standard deviation of samples. So we've been given the statistics on this sample, not just the raw data. So in 1936, R.A. Fisher published a paper investigating similarities and differences between plants, 50 in each of those species. The following table shows a summary of 2 of those species for their petal length. SUM, again, notice follows a normal deviation and the variance is the same between the 2 species. So that is an assumption that we are making whenever we run this test. And important to remember that if you were asked what the assumption was, you would have to assume that both of them are in a normal distribution and their variance, in other words, their standard deviation, no, just their variance is the same, the population. The size of the versicolor flowers seem to be bigger than the virginica. Based on this information, test this observance at a 1% level of significance. Okay, so as always, we start with our hypotheses. And as always with our null, it's just that they are, 2 are equal. So I'm going to go up here and label this guy as 1 and this guy as 2. Go ahead and see if you can figure out the alternative on your own. So we're looking at the text. And up here it says the versicolor guys seem to be larger than the virginica. And we are testing that observance. So from that piece of text, we're seeing that the versicolor, which is mu sub 1, are bigger than the other guys. So that would be our alternative. Whoops. Okay. So when we have just statistics, we don't have to put data into a spreadsheet. So we don't need to be in the spreadsheet for this test. So we just go to the regular calculator section of our calculator. What we do is we press menu, we go to statistics, which is number 6, stat tests, which is number 7. This is 2 sample, which we will always do 2 sample when we're given statistics. So we go to number 4, 2 sample. Now, here's where we flip. Instead of doing data, we do statistics. And I just went to the right and then scroll up or down. I picked statistics by pressing enter and press enter again to go. X bar 1 is the average of the first sample. First sample I've established to be this guy, so that's 55.52. SX1 is the standard deviation, 5.52. N1 is the sample size. So you have to make sure that you know what the sample size is. Often it's hidden in the wording of the problem. Sometimes it'll be given to you like really easy, but it's probably going to be hidden in the wording of the problem. So it says 50 plants of each of these species. So we're going to put 50 here, whereas X sub 2 is for our second sample. Still 50. Alternative is that mu1 is greater than mu2. So I scroll to the right. Mu1 is greater than mu2. Pooled always yes. And then go run the test. This is what it looks like when the test is run. So you can see that this is like, I'm scrolling down here. So down, this is what it was input as. I scrolled down again. This is the results. So doing this outside of the stats list, this is how it looks. Again, we can put down the t-value just in case some weird mark scheme cared about it, but we never use it. P-value is odd. Notice it says 9.2074956. But then it says E negative 20, which makes a lot more sense because P is a probability, which means it should be less than 1. E negative 20 means scientific notation, so I would write it like this on a test. And essentially that means that we've moved to this decimal 20 places to the left, which means that this answer, the probability, is essentially 0. We are so darn close to 0, we're just considering it at 0. So it's almost a null probability, which means 0 is less than 1%. Since P is low, we reject the H sub O. The probability of all of this breakdown occurring, given that the null hypothesis is true, is really low. It's really low that this happened this way if they were equal to each other. So we're going to say, okay, then they're probably not equal to each other. And in fact, we can see they're probably greater. So this means the iris versicolor has larger petal length. Okay. T-test is considered one test. And so I tell you that we have 3 tests that we're running here, but you can see that T-test has a lot of like variances, a lot of different things that can kind of like slightly manipulate the test. So there's a lot going on here. Example 5 is one way it could vary. Examples 2 and 3 kind of like solidify that information. Example 3 and 4 are similar, the same type of idea, whereas example 2 is a one sample and another like variance on the t-test. So it's really considered only one test, but there's a lot of tests within this test. So just be aware of that and trying to keep in mind what it all means. Good job today, and I'll see you in class.